Good evening, one and all. My name is Jaydeep Murthy, a first year student at NIT Allahabad pursuing a bachelor's degree in computer science and engineering. I welcome you again to an interesting session about the gripping topic, a subset of artificial intelligence, and that is deep learning, or in short, we can call it DL. Are you ready to listen to the inciting conversation today about this topic? Okay, let's get started. While discussing this topic, some of the questions one might raise are: what is deep learning? Where can we see it in our daily life? Is it significant? Can machines operate on their own without deep learning? To let out your curiosities, we divulge this session to dig deeper into this concept. Want to know who today's speaker is? I introduce you all to Mr. Srimouli, a competitive, passionate, and confident person who has been a deep learning researcher at IISc Bangalore and currently working as an SDE at Netcracker Technology. Mr. Srimouli completed his MTech in data science and engineering at BITS Pilani and his bachelor's of engineering in electrical and electronics at the engineering at Osmania University. Let's welcome him onto the screen to know more about him and his experiences in this field.
Hi Jaydeep.
Hello, sir. Nice to meet you today on this special evening.
Yeah,
Can
me
you
too.
please introduce yourself to our audience?
Okay, hi guys. I'm Srimouli. I have completed my bachelor's in electrical, and then I have also been a student at Indian School of Business in one of their flagship program called Technology Entrepreneurship Program, which is now known as EEP, which is Experiential Entrepreneurship Program. And later, I have completed my master's from BITS Pilani, and also I'm working as a software engineer development at Netcracker Technologies in Hyderabad. And I have been into deep learning research since a pretty much good amount of time. Yeah, that's pretty much about myself.
All right, sir. Can we know more about your journey in this field of data science and deep learning? How did you start and how is it going?
Yeah, the first interest which where I was interested in this deep learning field was when I have seen the movie Robo by
Right.
Rajnikant.
Yeah.
I was very curious when I heard about this humanoid robots and everything, and I really felt excited. But later, I was not sure how do I actually learn this stuff, because the
Yeah.
time when I started, there were very less resources because the all resources just came up in pretty much 5 years of stuff. And I
Yeah.
was into my undergrad in 2014. I didn't have much resources then, but yeah, that's where my interest has sprung on. And after that, I began reading research papers, journals, and all the mathematical stuff, what and where I can find, and I started
Right.
implementing them. And in the course of time, I was fortunate to get an internship from IIM Lucknow, where I worked on these data science methods and all, and Samir Mathur. So, and that's when I got to know a lot more, and I started going on deep and deep, exploring the field, because by 2017 and 18 there was a lot of content available online, and the only challenge what I had was to filter out what was needed. And I have been lucky enough to do that, and I could found peers who could help me on doing that, and yeah, that's how I started.
Okay. That's so amazing, sir. Everyone wants to learn more about deep learning from this session. Without any ado, I pass the stage over to you, sir, to get started with your presentation.
Yes. Okay, that would be great, Jayati. Yes. So yeah, again, hi everyone again. So yeah, this is a bit about me. As I said, I have completed my masters from BITS Pilani, and today, when I begin, I just wanted to start with the introduction to deep learning. So first, I want to set the agenda for this discussion. So the agenda here today will be I'll be discussing the high level overview of deep learning, because Moving on to the complicated stuff of deep learning would need a lot more of time. So I think I'll start about how we can start learning deep learning, and what are the options there for us to start learning deep learning, and how we can improvise upon them. And once my presentation is complete, you guys would be having time to post your questions. And yeah, any queries, we will be very happy to address them. Yeah, that's what is agenda. What's in my mind. So yeah, without not wasting any much more time, let's get started. So the first and foremost thing, so when anyone thinks about this deep learning or machine learning, AI, data science, these are all the kinds of terminologies that you guys come across, and it's often a very big confusion. What exactly are these terms? What is data science? What is artificial intelligence? What is real? What is machine learning? And where exactly are we going, and what I need to do? Even trust me, I also had all these apprehensions when I started. And having this apprehension is good, because in my point of view, these all the things mean one and the same. Maybe if you go explore very deep technicalities into it, yes, you might find some differentiators, but all these things are subset of one and other. So so in order to begin with that, so let's try to understand what exactly are this artificial intelligence, deep learning, and machine learning. So, artificial intelligence, you can see that as a very broad area where where any task which comes to helping the system learn, or giving it enough intelligence to make its own decision, you can see that to be an artificial intelligence stuff, right? Something like you can order an robotic vacuum cleaner, or you might be having one at your home. What it does, it just once you switch it on, it finds a path, it goes, it sweeps the floor, and done. And if there is nothing, it will just stop. So this is a very basic kind of intelligence that you can provide a machine. Or something like, you can if you just go to an industry of a car manufacturing, you have this lot of robots assembling the parts. It doesn't need to have a great amount of intelligence, because it needs to know what commands it needs to perform. And that is how you can call an artificial intelligence of an computer to be. But now, questions comes on, what if you want to add a bit more intelligence, like say you want to make a computer think something like, it needs to analyze a test case or a scenario which it has not seen before. So how does it do? So that is a basic extension to an normal intelligence. So that's where we are teaching the computer, and those things come under machine learning. But now you want to advance this stuff a bit more, like say you want to give it a bigger thinking ability. So that comes under deep learning. So yeah, this is pretty much how this goes on. So let's say, you've so I think I have made that thing clear. And if for example, if you want to understand really what deep learning is, something like, you can just take some example, like you are seeing a movie in a theater. As a human, you when you see a movie, you notice a lot of stuff. Like you notice how the actors are playing, what is the dialogue that is being said, what is the background music. So you analyze a multiple components. So analyzing these multiple components in a structured and in a complex fashion comes what comes into deep learning. But when you want to just know, like let's say you want to know high level stuff, like if a mail is a spam or not, or let's say you want to just provide some loan to some person, or let's say the most famous one, the personal assistants like Siri and Alexa. These can't perform a very complex stuff. They do fairly well where they can answer you what's the weather, or what's the news today, or let's say they can continue your conversation up to, let's say, like four instances, but beyond that, that is not possible, because that is the way they have been designed. And this comes under machine learning. Like, it is not thinking very deep, it is learning and it does its job fairly well. But and these both come under artificial intelligence, because artificial intelligence is a very big branch which comprises of all these fields. And when you hear the term data science, so data science, it is not something very special. What I would my perspective would be like, you need all the data that needs to be collected. Like, you need, for any of the machine learning or deep learning model, you need some data for it to learn from. So where you get that data and how you clean it up, how you make really good visualizations, or how do you understand the data, these things come under data science. But pretty much they are, I mean, they all do, I mean, in spite of having their distinctions, they all come under the same branch. So yeah, saying that, I'm just moving further. And this is a brief history about how this deep learning started off. In 1958, the first perceptron model was made. The perceptron model, it is not a very complex one. What it does is it predicts an output in ones or zeros. So let's say you take a color like black and white, and you give it to a model. It needs to classify all the blacks and whites correctly. And this was a very first uh, neural network thing that was going on. And there are other things called McCullough's neuron and these things, and these are basic stuff. Like, you take some two inputs and you get a single output, and you can stack these multiple things, and you can build a complex logic. But this is a basic stuff, and this started way back in 1958. And uh, and then there was this a famous algorithm called backpropagation, which came up in 1974, which has really created ripples in this field, and which has helped the scientists then to develop a bit more complex machines or complex models, because this back propagation does help a system to learn in a much more efficient way. And then there was this SVM, or support vector machines, and then going on to the convolutional neural networks for handwritten digits. And this CNNs are almost, I mean, anyone who starts with DL, they do know what exactly, I mean, they do know, come across this convolution neural nets. And then there were this restricted Boltzmann machines, a bit more complex algorithm. And then in 2012, there was this a challenge called ImageNet Challenge, and where Google has competed with one of a model called AlexNet, which can classify hell lot of images correctly. And that's the point when the development in deep learning has started to grow in a very heavy exponential fashion. Say from in my point of view, what I would like to view this deep learning stuff to be is before 2012 and after 2012. In 2012, we didn't have the end of the world as it was predicted by Nostradamus back then. But however, there is a breakthroughs coming in deep learning, and now when you see, you see almost an algorithm coming up, a new algorithm coming up every day, every hour, and there's a hell lot of research going on. But how this has happened is because after 2012 there was a great computational power that became available for scientists, like the more advanced GPUs and these all stuff, and they have become really affordable. And the advent of the cloud and these all things have contributed their own part in making the deep learning available for a larger mass of the audience. And that's how when people have started their experiments, and that's how we have a lot many algorithms nowadays. So yeah, so to start with artificial intelligence, as I said, artificial intelligence is something how you say a computer to perform its task explicitly. Something like you want to find a most efficient path, or you want a robotic vacuum cleaner to know which room it has to clean and how it needs to analyze its surroundings. These all stuff come under artificial intelligence, and artificial intelligence it itself is a very broad term, and we need it to be broken further till we get to the point of deep learning. And this is one of the famous quote which I really love, which is in connection to AI. That is, the key to artificial intelligence has always been the representation. So what it suggests is, so you want a computer, you want a system to make intelligent. The each and every aspect, or the majority of the contributor is how well you represent the data to the computer, because a computer on itself is a dumb machine. It's like a child without zero knowledge, and now you need to train it. How do you train it? You need a systematic way where you can help it learn, and that's how we can go on to the deeper models, or deeper tasks, and then we can perform deeper actions on our tasks. And coming to machine learning, as I said, machine learning is a subset of artificial intelligence, but it is a branch where you make an artificial intelligent algorithm, or you give it an ability to learn on itself. So it's basically like you tell you without like you don't need to put a lot of if else conditions, or you don't need to put a lot of do while statements, but you train the model to adapt to the newer situations and give a fairly good amount of response. And machine learning it itself is a very vast topic. Just like you can see, you have multiple branches of it. Like you have supervised learning, where you tell the model what is correct and what is not when you're training. There's unsupervised learning, where you don't know what exactly is correct or not. Let's say like I give you a billion points of some colors, and now you want to cluster them up. You don't know. I mean, you can use some algorithm like KNN, sorry, K means, where you get them all the means of the uh, colors, and cluster them. And uh, and for this you need not know what is the end result that needs to be, because you yourself don't know what exactly the output is going to be. And even in that time a machine should learn, so that you would say as unsupervised learning. And there is something again called as this semi-supervised reinforcement learning, where you play games or something. Like you have this famous game like chess, you want a computer to play. So when you make a move, the computer must think ahead, and then it should make a move such that it can defeat you. So these kind of stuff can come into reinforcement learning. And and there is one more thing which is coming up now, is a semi supervised learning. So why that is coming up is, you always can't find supervised data, because let's say you want to classify some flowers or something, and in order to get all the data to be labeled, that is a very costly affair. And when you are doing it on a scale of billions, it is not at all really advisable that you go noting each and every one of them. So semi supervised learning is a branch where you get to this both unsupervised and supervised learning. You apply both of those concepts. Something like you have some of the data which is labeled, and you write your functions in such a way that the model, while training, can itself give indication to the neural network that, okay, this is an unseen data and we don't have a labeled data, but however, based on the previous experiences, this can be sort of this thing. uh, and it can help the computer to learn that, and that's how a model is trained. And this happens over a long amount of time, where the model reaches a very efficient output stage. So this is about machine learning, I would say. And there are a lot. I mean, this itself is a very big task, because each and every uh, 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 topic of machine learning itself can demand a lot of uh, time to explain or get the things clear. Just take this to be a high level overview. And now we come to our topic, that is the deep learning. So, what exactly are we doing in deep learning? And what exactly is it? So, imagine this. Now you're seeing this video stream, and I'm making a multiple hand gestures here. I'm talking. At the same time, there is some background. You might be getting some noise, probably, or not. Or let's say I'm moving here and there. So these are a multiple tasks which I'm moving. But you're seeing all these tasks on the screen, analyzing them. You see that my shirt color is blue, and I'm having a Bluetooth headphone, right? And then I'm just sitting in a chair. These all things, these are a very complex analysis when you drill down or when you think very closely, because a computer, it on itself doesn't know how to do it. But our human brain has been trained since many centuries, and that has been an integral part of our DNAs, where we have all the genetic code which can do all this complex stuff for us. But a computer, it doesn't have that. So for in order to do that stuff, we need to tell the computer or teach the computer a bit more than machine learning stage, and that we can call it as a deep learning stage. And in deep learning, majority of the things are the first and foremost thing what you hear when you hear deep learning is a neural network. What exactly is a neural network? Neural network is not a complex thing. You can just you must have read this in your ninth class or 10th class biology, that brain is made up of neurons, where each neuron is connected to other, and there are almost like 4 billion neurons in your head, and they all constantly interact with each other with electrical signals. Like one neuron is responsible for sensing the touch, and that is sent to another neuron, and those all things are processed. So we are trying to mimic the same kind of behavior to the computer, because one thing what as humans we know is the processing, whatever is happening inside our brain, is happening through neurons. And what if we can give the same ability to the computer? What if we can develop neurons itself in the computer, and we can help it learn? So that is what is deep learning. And for deep learning, neuron, in the sense, we can't really get a biological neuron embedded to a computer. So what we do take help of really complicated mathematics here. We take the mathematics, we apply some mathematical function, and then the output of that function is given to the next neuron, and that refines that output more. And this happens in multiple iterations, while a computer can reach to a final conclusion. So this is how this happens. And yeah, some of the common deep learning methods what you can come across are this convolutional neural networks, which are widely used in image recognitions. Like, so any basic tutorial what you take of an image, it applies convolutional neural network. What it does, it slides a window over an image and then understands the edges of the face, then understands the features of the face and gives some output. That is what a convolutional neural network is. And you have some other things called as recurrent neural networks, or LSTM methods. These two both are used for sequential data. Like, you want to predict a caption. Let's say, like, I'm speaking right now, and let's say there is a subscript that could be generated. So, the subtitles can be generated. So how does that happen? Because it needs to guess what I can say in the future. So for such kind of task, we can use this RNNs and LSTM networks. And there again comes these another kind of method called autoencoders. This autoencoders are also a really a great source of or a great techniques where you can extract different features from an image, or you can first compress the data. It is something like what an autoencoder does is it takes a large amount of data, it compresses into an embedding space, let's say like a small subset of space, wherein it compresses the data which you are giving as an input, and now you train a decoder to guess the input what you have given. So this is how a basic autoencoder works, and you have multiple autoencoders like denoising one, stacked autoencoder, variational autoencoder, sparse one. So as the name suggests, a denoising would be used when you want to denoise an image or denoise an input signal what you have uh, given to the network. So maybe whatever I'm saying, some concepts can be going over your head, or something might be confusing. But what I'm trying to do is I'm trying to give you a high level overview of what all the techniques are available in deep learning here. And the autoencoders have a really great applications where you can use it for image predictions or image generations. You can do it. You can combine the convolutional neural networks with autoencoders. You can build models for audio classification. You can do that, or you can build really good models for image classifications. So there are many applications there what you can do with autoencoders. And then again comes the famous algorithm called generative adversarial networks. So these GANs are nothing but they take noise. They are a kind. What how I remember GANs is it is a kind of a autoencoder network where you have two components. One is like a generator and other is a discriminator. You can't say they are autoencoders, but what that is a way how I see them, because the generator is something which generates some random image, and discriminator is a algorithm which says, okay, if this is a desired output or not. Based on this, the model weights get adjusted, and then we can develop a model called a GAN model, which can predict or which can generate images, which can really take, let's say, like there are multiple use cases where you take a human face input, and then you can generate really unknown human images. And yeah, that's very much possible with GANs. Like, say, if you have seen Mentalist, and in the season 7 there is one, Mentalist is a series. In that, you in season 7 there would be one episode where one computer operator would be generating multiple images of some convicts, where who could possibly have committed a murder, and that's how the team would be able to catch a suspect who has escaped. And this is one example. And with GANs, you can create a lot of things. And yeah, one of the famous example what you can Google right away is these fake videos what you can generate. Like you speak yourself out, but you can impinge your facial movements onto some other person's face and make them look like they are speaking. And they are called deepfakes. There you can use these scans, and there are a lot of applications for these scans. Like you can also use them for super resolution or colorizing your images. Uh, uh, and many more things. So these are some of the famous deep learning methods. Like you take any kind of deep learning paper, you will more or less find an application of these things. It might be a computer vision problem, or it can be an NLP problem. It's fine, but somewhere or the other these concepts will definitely be applied, because these are the uh, five things which five methods which I have come across very much in any researches what I have seen. And why do we use them? Because they do give a very good or very desired performance levels. And now again, now moving on further, this is one of the main which I like. Just you can replace this data scientist with an ML engineer, an AI engineer, anything. It is something like you see a lot of people like to talk about data. Like, okay, wow, this is a humongous data. Like, say you take this all the Instagram reels, you have a huge amount of data. Like, people dance, people sing, or people act. You have huge amount of data, and people are really want to really explore the data. But when you talk about the mathematics behind the algorithm, it might be an ML algorithm, it can be a deep learning algorithm. People tend to distance themselves from that math, because the math gets complex and complex when you try to see go into the deeper stuff of any algorithm. It becomes really like very complex. Like you feel wow, what exactly I'm doing, what's happening inside the model, because you don't know, you can't see what is exactly happening in some 500th iteration, right? Because that might be going wrong and you don't know that. So how do you know how a model can perform is there is no other shortcut there. The only thing what you need to do is you need to be good with your basics. Like you need to learn the underlying mathematics for any in order to start with deep learning. Like you need to know what exactly is a deep linear algebra, or you need to know how do you what is exactly is a determinant doing, or you need to know what exactly is a rank of matrix indicate. So these are really basic stuff. So if you take determinant, if I just give you a 2 by 2 matrix like ABCD, if I would ask a square matrix, I mean, and if I would ask what exactly is a determinant, you would just give me an answer AD minus BC, right? What exactly is it doing? It just transforms all the vectors in the vector space into a single point, and that is what a determinant signifies. And this is a kind of understanding that you need to have when you want to go into the deep learning stuff, because the fair amount of stuff like implementing some caption generator or making a chat bot, these things are pretty much easy because many people have done it, and you have lot of resources where if you get it out you can go there, you can check and come back. But what if you're trying something new? Then that's the challenge what you get if you don't know the mathematics. And I would say this roadmap is not something like you start, you master yourself, and to the end, voila, you are a great ML engineer. This doesn't happen because this is a continuous learning stuff. You need to know them because you can't remember all the heavy mathematics in your head, and you can't know all the deep learning practices. So the thing what I personally do is, uh, I know the basic mathematics, what happens, or when do, or what happen, when do I need to apply some determinant, or what happens in linear algebra kind of stuff, what happens in a graph theory. I know the mathematics. Then I understand how a deep learning algorithm works, like say how a CNN works, how the two-dimensional convolutional neural network works, how a one-dimensional convolutional neural network works, or how an RNN works. I go to understanding that on a technical level and understand the underlying mathematics. Because if you want to understand only the model, it doesn't it is not easy, and it becomes really complex. But when you start with the math behind that, I'm pretty much sure you can really easily understand what exactly is happening. Because at the end of the day, what a computer knows is only ones and zeros. So everything what you're doing, it's being converted into some math operation. So just remember, math, often people think it's really hard or something. Often people are very fearful about math, but in my view, math is a very beautiful subject. It is like, uh, it is a language of the universe. So you take any kind of subject, any kind of subject which is really technical in sense, or you take geology. You know math, you know geology. You can understand what exactly is what an author is referring. If you understand mathematics correctly, you can understand an electrical engineering, you can understand communications engineering, you can understand computer science engineering, you can pretty much understand any branch of engineering if you just know the math. So what I would say is, get to know the math correctly, or understand the math in a really good way. Don't fear from it, just love the math. Because of all the languages, maths is a universal language. Because I don't know, even if there is an alien invasion, even it has to obey some mathematical rules there. Because you can always deduce math, and it is absolutely crystal clear. It doesn't have any prejudices or anything. It is really crystal clear subject. So understand the math, then learn the deep learning practice like CNN, RNN, and everything. And then search for research papers in that area. See how people are applying that. And when you see some research paper, they do apply two to three complex together, two to three topics, and then understand the math again from it. Then again understand your model, and this happens in a cyclic fashion, and that's how you can really master yourself in deep learning stuff. And moving on further, and these are some of the trending research areas which are currently in the field of uh, uh, deep learning, and there are many more. And but these are the areas where, uh, I mean, computer vision is an area where, like, of you just randomly pick some 10 papers from deep learning, you'll find a majority of them to be computer vision. Because that has become a really like an overrated field, and everyone wants to get into it. And people apply a lot of mathematical methods there, they get results. And the most important part is computer vision algorithms have really great accuracies, near to human accuracies, and that's the place where why people like it. Because you don't expect your model to just give 50% accuracy and you say, well, I got a really great model, right? You want near to 100, right? So that's the reason why there is a lot of research and CV going on. And there are other branches too, something like PGMs, which are probabilistic graphical models. That is one part. There are something called as graph neural networks. These two think about the things in terms of graphs and a pure mathematical kind of stuff. And then there is a lot of research again going on speech and audio things, like what is the genre of a music, or let's say what is an emotion generate. See, now when I'm speaking, I'm making multiple lip movements, but what if there is no audio? How do you interpret it? and and those kind of stuff also is going on, like you see the lip movements, and the subtitles are automatically generated. I mean, it is not so accurate at this point, but yes, a lot of research is going in that area. And after computer vision, there this NLP is a part where you find a lot of people into it, because even NLP is really has become really easy nowadays, thanks to the transformers, but these kind of models, where you just put whatever data you have and you can deduce your results, and you can get the sentiments in the text. You can identify if the text is correct or fake, or you can do a lot of stuff in NLP. And then again comes human computer interactions, and this is one of the branch where there is a really good active research going on, because at the end of the day you need to have a decent human computer interaction. Without that, things might go off hand. So that's the point where you have responsible AI kind of fields also coming up. Maybe this thing, responsible AI, would be something like some professional ethics kind of thing, because you need this is all about how you enforce, or how do you see your AI algorithm or ML or DL algorithm to behave responsibly, because this topic has really potentials to uh, make a lot of generative actions and also destructive actions. So no one wants destruction, right? So that's the point where you need to make, or you need to work on use cases which are really productive for the human race to move forward, but destructive things, that needs to be avoided, and that is what is done in responsible AI. And and there are a lot of other stuffs also going on in these areas. uh, Maybe you can just google them up. And what I can suggest you is, if you want to start off with deep learning, you can start reading these books. I wouldn't say just start from the page one, end at page 900 or 1000, or let's say the last page of the book, and go through them. But what I would say is, these can really give you a mathematical understanding about whatever thing you are learning. So uh, so this, you can just take a screenshot of them. And these are the books which I personally liked it. If you take this deep dive into deep learning by Aston Chang et al, this book has really good amount of practical examples in PyTorch and Keras. And this deep learning by Ian Goodfellow, which is often considered to be a bible of deep learning, that has a lot of theoretical stuff. And this machine learning book HOML, by Orly and Sharon, and this is also has a great stuff on machine learning. And you can go, this starts from the absolute basics to a hero level. And yeah, and these all are the top level books which you can refer. So yeah, this you can take a look even after the session, because you'll have the recording available. And these are some of the famous frameworks that you use to train the deep learning models. You might have heard of TensorFlow, Keras, and PyTorch. They're pretty much famous because all the, I mean, majority of the industrial or uh, practical use cases, or live use cases, they do employ TensorFlow, because it is very easy to write. And most of researchers like using PyTorch, because It really gives a very great intuition about what exactly you're writing into your code, and that's how. And Onyx, MXNet, and Cafe, they are also a really great amount of they are really great frameworks. And majority of, like, you can find these implementations coming into TensorFlow and PyTorch also. So it doesn't really matter, but the thing what matters is how do you understand the basics, or how do you understand its functioning. Let's say you take a TensorFlow framework, you need to understand what are the modules that can be done. If you take PyTorch, what kind of stuff you can do there. If you take MXNet, what exactly you can do there. Because at the end of the day, what exactly is going to differ is only the syntax. And apart from that, you don't have any other things that are new. So it is absolutely up to your choice, where you can select your desired framework and start working on. If you would ask me my personal favorite, I would say I like PyTorch and TensorFlow a lot. So yeah, and these are some resources what you can start off for deep learning stuff. You can this Andrew Ng's course is like you can find it as a suggestion available anywhere, because those lectures are really very descriptive. They give you a very great understanding about what exactly is this MLDL stuff, and there are a lot of videos on at MIT OpenCourseWare which are really good. I personally like the mathematics by Gilbert Strang. He's a professor at MIT. He explains the concept very great, and there are great YouTube channels like Three Blue One Brown, Chris Nayak's, Sentex, Abhishek Thakur's, etc. These things you can just go through them, or if you just open up LinkedIn, you see a lot of people say, "Wow, I have made this model, I have made this model, or I have implemented this." You can just go explore the how they are doing it. Maybe if you want, you can talk to them. You can understand what exactly is going on, because it's all you don't find any structured way here. You need to talk to people, and then you can get to learn a lot of things. And this fourth suggestion is what I love the most, or what I follow, because I really like to take advantage of these recommendation systems what have already in implementation at Instagram or LinkedIn or Reddit. Like, you follow some hashtags, or you like some post which are related to one feed, and the other things just keep popping up. So you don't need to worry, because the recommendation systems take care of all the trouble to give you the best resources. And you have always have the Kaggle competitions or Kaggle notebooks available for you to go learn, experiment. Yeah. So now I come to my end of my talk, and I would really love to hear the questions from you guys. Yeah. So if you have any questions, you can shoot them in the come YouTube live chat, and I can answer them.
Thank you, sir, for such an amazing presentation. There were many
Thank you.
important topics. There were many important topics that were brought up, and I'm sure that many students are having a lot of doubts now. As we can see
Yes.
that many questions are popping up. Okay, sir, shall we start taking out the questions from the live chat?
Yes. Yes.
Okay. Can we please have the first question? What are the various career opportunities in this sector?
Okay, this is a very broad question, and that's rare. So there are a lot of things, but if you want me to break them down, one thing would be research side, where you involve with major R&D institutes and you engage in upcoming researchers. And the other thing is implementing the existing stuff or the prevent stuff onto a production level. So the choice lies between in your decision, and you have both the industries open for the talent in this. Like you have all the top companies like Netflix, Google,
Right.
Microsoft, or
Yeah.
even not even the companies you hear a lot.
Hmm.
Even everyone is in the race of deep learning. So the practical applications are there. Just the only thing is you need to know what exactly you want to perceive here, and try applying opportunities there. There are a lot of opportunities in computer vision, NLP, those kind of
Right.
stuff,
Right.
and even research opportunities at institutes like Stanford or MIT or CMU or IISc or IITs. They do have a lot of people working on research. Just main people, just get to know what exactly they are doing, and maybe you can work with them. Yeah.
All right. Okay, can we have the next question? What is the use of deep learning in today's age, and how is it adding data scientists?
Okay. So, Rajeshwari, this is about deep learning is on almost each and every aspect of your life nowadays. Let's say like you open up some Amazon, you find some product, and then thereafter it starts popping up everywhere as ads, and you see Instagram, you like some photos, it keeps on recommending relevant stuff. So,
Right.
and you see some YouTube, you find recommendation videos. So these all implement very complex deep learning algorithms. So deep learning is almost in every walk of your life. And to say how it is adding data scientists, because data scientist is a broad term, like you, for all these models to work, you definitely need the data, right? So data scientist is someone like who handles who takes care of the data and also takes care of the model.
Yeah.
And if there is someone who is only taking care of the model, you call them as an ML or DL engineer. Or if you take someone who is only taking care about the data, you call him as a data engineer. So yeah, that
Okay.
is pretty much.
Okay. Can we have the next question now? Describe your work experience at Netcracker and
Okay.
IICSC.
Okay, great, Gayatri. This is really good. My work experience at Netcracker is really awesome. I do have a really awesome team who support me at various levels. Like for you to survive in any corporate company, you need to have backing of your people also, because
Right.
uh, that support or the emotional support or the technical support what you get, I do really like that work culture at Netcracker, and Netcracker is always open for opportunities, and people are like really very interested in getting people. So yeah, that's about Netcracker. And IISc is something like it is where I do my research, where I'm involved, and my experience there has been really good. So I get to learn about how people think about a research problem.
Yeah.
How do you approach, or how do you put forward your research idea in deep learning, because deep learning stuff definitely needs a lot of backing and a lot of expertise or people to guide you there. And I
Hmm.
feel that talent is really available at IIS, and even that talent is available at many other places. But as I have seen people at IISc, I am saying that. And there are many IITs and IITs and even many local colleges also having great amount of people into this area.
Right. Okay, can we have the next question? In real life, where can we see the applications of this technology?
That's actually so. That's a good question. But this has been I just covered this a bit
Yeah,
earlier. But however, I would like to repeat. So Instagram, Facebook, or Amazon, Netflix, these all. I mean, any recommendation system you take uses this kind of technology because it needs to build a social profile of you because they want to serve you with really relevant they want to serve targeted advertisements to you.
like
Yeah,
the user feedback is required.
exactly.
Okay, we'll just be taking one more question. So please just play it on the screen. So, what are deep learning frameworks and tools?
Okay, Harshita. So, deep learning framework, I'd say a framework is something like you have set of the tasks which are already built in the pipeline. You so that you don't need to write start from the scratch. It is something like you go to an IKEA store, you get the table and the legs. You just assemble it. You don't
Yeah,
need to make the tabletop. You don't need to make the legs and these all things. So this is what a framework is. And a deep learning framework like Keras or PyTorch, they do have the implementation of the generic stuff like a convolutional filter. They do have an implementation of that. And now it is in your hands. How do you use it?
hmm,
And where do you use it? So that is in your hands, but the basic code is already built in that framework. And
right.
tools are nothing but they just automate the stuff. And yeah, pretty much I would see tools are something like maybe you have many tools in this area, and they can that something like you can just drag and drop the convolutional block or RNN block or LSTM block, and the code gets automatically generated. So if you would ask me personally, I would like working with frameworks because it does have some boilerplate code already available. Now it's only in my hands to uh, configure it. But
Yeah,
tools are something like they are highly specific. So I don't like using tools personally.
okay. All right, sir, we've reached the end of this session. I feel so
Okay,
nice talking to you, sir. So,
great,
how do you
Jaydeep. I
feel?
also have.
Yeah. So, how do you feel about this interaction with us today?
I really like this. I really like this initiative because out even in 2022, we have a lot of stuff where you can get knowledge, but it is
Right.
not structured.
Hmm.
So you need to develop the structure, right? So I think initiatives like this really help building that structure and can give the users really a one-stop destination, like how they get started.
Yeah.
So I really enjoyed this talk.
Okay, sir. So, I want to thank you again on behalf of our whole team for accepting our invitation and giving us your precious time from your busy schedule. It was an excellent
Thanks, Jaydeep.
experience interacting with you, sir. Best of luck for your upcoming endeavors in the future, and thank you.
Thanks, Jaydeep, and all the best to you too and your guys as well.
Right, sir. Thank you. All right. That's it for the day, viewers. Join us for many upcoming sessions. Let us go tech together. Stay tuned to this channel for more captivating talks. This is Jaydeep Murthy signing off. Thank you.